Howdy once again, this is Tubalcain, your YouTube shop teacher, and this time with episode number 27 of my What Makes It Work series. And I decided some time ago, you might have seen it in one of my auction videos, where I came home with a box and it was just loaded with indicators and indicator parts. So at that time I laid one of these aside and decided there was no stem on this anyway, that I would show how it works and just take it apart and probably end up throwing it away for the good of the cause. But everybody has this type of indicator around their shop, and I probably got 6 or 8 of them, including some Starretts that are based on a slightly different principle. But for those of you that wondered how these work, and they're simple enough, and possibly this does not warrant a full video, but it's going to get one anyway. But in the meantime, as I was planning this, of all things, a man, and I'll talk about that in the next video, said, I'm going to send you a Noga type magnetic stand, and that would be this kind. Would you be interested in showing how this works? So in an upcoming video, forget about the base, because all those bases magnets are the same. I'll be talking about how this articulated arm works, so watch for that. Alright, now to the business at hand. As you know, this kind of magnetic base has a switch on and off, and it's not an electromagnet. So really what you're doing is just rotating or reorienting the magnets in there, or magnet. There's just one in there. And I had to take my pocket knife that they did take away from me at the Grand Ole Opry. I was quite mad. But I got it back. But I had to peel this off. This is so cheaply made. You know, these are only $10 or $12, and so that's adhesive. But what's interesting, here are the patent numbers if you want to look those up, and I did, specifically the second number there. Just go to Google Patents and you can read all about these. But before I talk about that anymore, all we have to do then is to remove these 2 screws. And then this little die-cast plate comes off. By the way, this is old enough to where it's made in Japan. And this will come off. That part is really kind of nicely made, but I don't know why they have a plastic knob, and all of these have plastic knobs except for this Central brand that I have here. And I think I have some other brands too, maybe an older Enco. This is probably a pretty old one if it's a die-cast handle. But you know, all the ones from overseas are plastic. So you take the handle off, and all that does is to rotate the magnet. Takes a little more leverage than that. We are rotating the magnet. Stainless steel. So now the magnet's in the energized position, and it's not energized. And they really greased this up. Alright, I got my pliers because there's quite a magnetic attraction here. Watch this. Almost like it's a solenoid, but of course it's not electric. So there it is. I cleaned it up a little bit because there's filthy black grease in there, so I will re-grease it before I put it back together. This little spring here keeps it from hitting the bottom. Again, that's just where the switch handle goes to orient it. It's very, very powerful magnet. So that's all there is to these things, just a matter of turning the magnet one way or the other. And in the patents information, they talk about lines of flux and all kinds of scientific things, because I guess that's how they got around the patents, or make a patent that's slightly different from others, because everybody and his uncle is making these, and I don't know about the patents, but the patent applicants here are Japanese, but there's a good picture of it. And you can see pretty much what I showed you there, and they're showing the North and South Pole. And there's about 3 or 4 pages of legalese, and I looked up several others too, and they spend quite a bit of time and pictures talking about all the different lines and force and all of that with magnets. So that's a graph of how the magnets, the attraction is turned on and off. Probably not something that most people want to read about, but that bottom number there is the patent that I just showed you. Now, those are U.S. patents, but this patent, yeah, they were Japanese names that I cannot pronounce. Here's a magnetic chuck, a relatively small one, off of a surface grinder, and if you ever wondered how those work, it's really a very similar deal to what I've shown you here. However, in this small chuck, you can see that there are, what is it, 1, 2, 5 magnets in there, and they're all being turned or oriented at the same time by that lever. On the larger ones, you will see many more poles or many more magnets, and the more magnets there are, the more the attraction for larger pieces that won't get thrown off on a grinder. Also, some magnetic chucks on surface grinders are electromagnets, but you'll see an electrical switch rather than a mechanical lever type of switch. So in effect, what we're doing here, as demonstrated by this bar magnet, is just rotating the magnet 90 degrees. Only this is the magnet. Now, there may be some of you out here that are not familiar with what these are and what the purpose is, but we put a dial indicator on these. Let me show you a complete one here. And we would indicate something in on a lathe or other machine. This allows us to fasten it onto the machine and different onto the bed or the carriage or wherever we're going to fasten it, and then also loosen it up. Now, this is going to attract chips on the lathe, so it's very easy to turn it off and clean the chips off. So, and here's one that can be mounted in 2 different positions. Well, that's it. That's all there is to this. I'll put her back together. I'm going to put a little grease on here first and reverse the process as you watched it before, as you watched me take it apart. Hope you liked the video. Be sure and watch the upcoming one on the articulated arm, which will be number 28. This is tubalcain saying so long for now. Thanks for watching.